Hello, we have been taking up the rules for congruency of triangle, and that we had discussed previously about the SAS rule. In this session, we will be taking up question which applies SAS rule. Thereby, I am writing a question and will be writing few short forms so that I finish writing the question quickly. In right triangle ABC, which is right angled at C, M is the midpoint of the hypotenuse AB. C is joined to M and produced to a point D such that DM is equal to CM. Point D is joined to point B. Let us first draw the figure to this question and then I write what are we supposed to prove. Let me draw a right angled triangle. This looks more like a right angled triangle. Oh, I should keep this a bit reduced so that, okay, this is C. This will be, we have to take this as A, B. It says midpoint, I assume is here. That will be M. It says C is joined to M and is produced to a point D such that DM is equal to CM. I hope I've drawn that right. This is M, this is D. It says point D is joined to point B. So I have to join this. Now what we have to do, the first part says prove triangle AMC congruent to triangle BMD. AMC BMD. Now, because it has informed us M is the midpoint, that would make CM equal to DM. Or if I am writing in triangle AMC and triangle BMD. So I'll write MC is equal to MD. Because M is the midpoint of AB, this two will also be equal. So AM is equal to BM. And also these two are vertically opposite angle. So I write angle B, I'll write this first because I have taken AMC on the left. So I'll write angle AMC is equal to angle BMD. These two are given to us and this is a vertically opposite pair. So that makes SAS rule criteria applied to AMC and BMD congruency. So triangle AMC is congruent to triangle BMD and in the bracket we write SAS congruency. What was number 2 to be proved? We have to prove in number 2. In number 2 we have to prove angle DBC equal to angle ACB. Let us mark which triangles they mean. DBC and ACB. This and this supposed to be equal. Now, as because we have already proved the congruency of these two triangles, angle ABD, this part is equal to angle BAC, ABD, so CAB, CAB. This is by CPCT. These two red marked angles. Now AC and BD are two line segments on which AB is a transversal. Let me highlight that figure. See, sorry. If you look at this and observe it carefully, these are two line segments CA and BD, and these two form alternate angles. If these two are alternate angles, thereby making AC parallel to BD. Here you can write AC is parallel to BD, and in the bracket you can write ABD and angle CAB make alternate angles as alternate angles on AC and BD, as AB is a transversal. That would make, if those two are alternate angles, so angle DBC. Now look at these two. If I have proved those two to be parallel lines and BC now act as a transversal in this line, angle DBC will plus angle ACB should be 180. Here you write BD parallel to AC and BC is transversal. They are on the same side of the transversal and that they are supplementary. Now we had already been informed that ACB was right angle, that is, this part is 90 degree. So angle DBC will also be 180 minus 90, and that makes it 90 again. So that is also proved. Now it says we have to prove triangle DBC. That means this whole of the triangle I again have to highlight this part and this part. This question is asking us to prove DBC congruent to ACB. In that case, it will be very simple because we have proved DB. Okay, we had already proved the congruency of these two pink triangles. Thereby, by CPCT, we could have derived BD equal to AC. I write this here. Third part, by CPCT we must have derived BD is equal to AC. Here you can write CPCT. We also had now proved DBC to be 90 degree, and it was given ACB to be 90 degree, and its common is BC, the base is common. So thereby making these two triangles congruent. Now we move on to another question. The figure is given to us. I draw the figure first. It says this one is named as ABD, this is C, and this is E. It says AC is equal to AE, this is informed. It also says AB is equal to AD. Angle BAD is equal to angle EAC. We have to prove BC equal to DE. So let us join DE. We have to prove BC. This is to prove BC equals DE. Let us take the triangle ABC. I write in triangle ABC and triangle ADE. I think it would be better if I highlight them. ABC, I said. This is ABC. And with ADE. These two triangles, once we highlight, it becomes easier for us. It is given AB to be equal to AD. That's given to us. We also been given AC equal to AE, that is also given to us. Alright. We now only need to prove this whole angle equal to this side whole angle. It will now, that will help us to prove by SAS rule. To do so, we write, it is given that angle BAD equal to angle EAC. Now this and this, if I subtract this middle part, that is DAC, is common to both sides, so I'll add them to both sides, both angles, sorry, plus angle DAC. And this side it will be EAC plus DAC, thereby making the whole as BAC equals DAE. So I can write the third part here, BAC equals angle DAE, thereby proving the congruency of these two triangles by SAS congruency. The bracket here I write SAS congruency. Once I prove by SAS congruency, BC and DE will be equal by CPCT. So BC equals DE by CPCT, that is congruent, corresponding part of congruent triangles. Hope you followed it well. Thank you.